Hi, this is Stephen Brower. This is meant to be an addendum to the chapter on binary search trees. And it's meant to piggyback the addendum on linked lists. So the linked list addendum showed doubly linked lists where each node points to the previous node and to the next node. And we can do something similar to that in trees, where each node in a binary search tree, besides having the left and the right links for pointing to the left and the right child, can have a link pointing to its parent. So here's a tree with grape is at the root. We have cherry and mango. And so we have, the left and the right from grape. Cherry has no children, mango has no children, but now if we look from cherry, there is the parent going to grape, and if we are at mango, we look at parent going to grape. Now this being at the root, if we take a look, there is no parent. Well, there's no parent. What that can help us do is, remember in trees part 1, 2, 1, in trees part 2, one of the conditions that we use for removal from the binary search tree relied on having parent. And parent meaning we actually created a second pointer to go in tandem with cursor. And as we move cursor down the tree, we move parent down the tree as well. Well, now when we add items to the tree, maintain the parent, and remove maintain the parent, then we can just use the parent field. So now this would be showing for adding lemon. And so we'll start off by establishing our cursor. The cursor is going to move down the tree until we find the node we want to create from. And so what we want to have is we want to create the node to the left of mango, because lemon is less than mango. So in terms of this statement right here, the right-hand side first, this part here, this new BSTNode, with the BSTNode, we now are going to have one additional parameter. This is going to be the parent, left, right. So we're going to create a new node with its value, which is lemon. Its parent is going to be cursor, meaning this is going to point to mango, and it's not going to have a left and a right. Once the new node is created, then the set left, this is going to point to, now cursor set left, to this new node that was created. Now if I just get rid of the chicken scratch, then this is the new node that has been created. So for the new node we created, we maintained the parent to the node that it was created from. On removal, now suppose in this case we want to remove mango. I don't want to remove mango, but for this example our reuse, we'll remove mango. So we begin with cursor at the root. We're wondering, see if we can find mango. Well, grape is not mango, so cursor moves to the right. And now we're here. And now we found what we're looking for. Now, in terms of the conditions, this turns out being condition 3 from we had trees part 2. Remember, cursor is not at the root. Cursor is not at the root. There's no left child, and there's no left child. Okay, so here we're going to see is cursor. Cursor is pointing here. Is it cursor get parent? Well, cursor get parent brings us to here. Get left is here. So no, it's not, because cursor is pointing here, and the cursor get parent, get left is pointing here. So we're going to go to the else. So in the else, cursor get right, and let's see if I can do the highlight here. The cursor get right is going to be this, and then we're going to set its parent. Well, the parent, that means this thing right here, we're going to set it. And we're going to set it to cursor get parent. So the cursor get parent, that means this is going to point to the parent of cursor, which is the mango. So what this takes care of is now, for this right here, which is to the right of the item we want to remove, it is now pointing to what its new parent will be. But what we need to do is we need to take care of the right-hand side of the parent. So the cursor get parent, so cursor's here, get parent brings us here. Set right, so that's setting this value to cursor get right. Well, cursor get right is pointing here, so now that means that that right part is going to point here. Let me go and remove all this chicken scratch and kind of move the node logically to where it is, and that's where it ends up with plum being to the right of grape. So by maintaining the parent on the node, yes, it is one extra thing that we have to do on adding, and it's one extra thing we have to deal with in the removing. But the thing is, then we don't need an additional pointer like we did in the algorithm previously, maintaining a parent. Parent then is embedded into the tree. Well, that's just one thing for right now regarding having an additional field in the node.